Last lesson, we introduced you to radians and angle measures, and today we're going to take that a little bit further. So we're going to go over coordinates of a point on a circle centered at the origin, and then we're going to expand that to the unit circle. So it says, given an angle in standard position on a circle with a radius r, centered at the origin, there is a point P where the terminal ray intersects the circle. And so a diagram of that is shown right here. So here is my circle centered at the origin. This would be considered the angle in a positive way. Remember, negative is clockwise, positive is counterclockwise. So we're looking at this angle here. Radius r would be this right here. And so if we dropped a vertical line right here, that creates that right triangle we talked about last time. And so this x is the horizontal displacement and y would be the vertical displacement, which would get us to this point P. And so then we talked about cosine is the adjacent over the hypotenuse, so it would be x over r, and sine of theta is the opposite over the hypotenuse, which would be our y over all. So recall that from our last unit. We're going to use that for a second. It says for each of these two equations, we can multiply both sides by r, and the results are x equals r cosine of theta and y equals r sine of theta. Thus, the coordinate points P are r cosine theta, r sine of theta. So this would be the x value, this would be our y value. And again, we got that with cross multiplication. We can solve for this x by multiplying that r to the other side. So the x value comes from the radius times the cosine of theta, and the y value comes from r sine of theta. So we're going to look at some questions that would need that. It says example 1, the figure shows a circle at radius 4 along the equilateral triangle PQO. So PQO right here. There's an equilateral triangle, which means that we have another one that would go right here and another one right here. We're dividing that top part into 3 parts. And so it says, which of the following gives the coordinates of point Q? And so we want to talk about this one right here. Since this right here is 60 degrees, because it's an equilateral, then this one is also 60 and this one is also 60. Right there. All right, at 60 degrees last time, we learned that that is pi over 3. And remember, in AP Pre-Cal, we're going to talk about everything in radians, so I just want that as a reference for you. So our radius is 4, and we see that again right here at this point 4, 0. So we know that from the center to the outside of a circle is 4. So I'm going to go ahead and label that as 4 and that as 4 since it's equilateral. All right, so if this is 60 and this is 60, we're talking about the 120 degrees. So that, again, that's just for reference. We want to work with our radian measures. And so 120 was the same thing as 2 pi over 3. So the angle that we're looking at here is 120 degrees. It started from the 0 here, which we start in standard position at that positive x-axis, and then 60 plus 60 gives me the 120. Now, since our radius is 4, we know that the r value is going to be in the direction of 4. All right, so we want to talk about point Q right here. And so if we think about that, point Q is this one right here. P would be x comma y. And then last time we talked about that's a reflection across the y. So it would be negative x comma y. And so now we have our x value and our y value here. And so we said the x value is r cosine of theta. Now it came out to be a negative, so we know that's going to be a negative. The radius is 4, and the angle is 2 pi over 3. So we see that right here, negative 4 cosine 2 pi over 3. And then here, for the sine value, it's a positive y, and so my y value would be equal to that radius of 4 times the sine of 2 pi over 3. And so the answer here would be D. This is my r cosine theta, r sine theta. All right, let's look at another circle here with similar information. It says the figure shows a circle of radius r along with the line y equals negative x. So here's my line, y equals negative x. We know that's the linear parent function with a negative slope. So it goes right through the center since there's no y-intercept. And so there is that drawn, and then my circle is right here centered at the origin. They intersect at the points R, right here, O, and P. If the coordinates of point P are 6, negative 6 root 2. So I'm going to go ahead and label that right there. What is the value of R, our radius? And so we want to talk about the radius there. And we learned, again, our radius right here is from the center to the outside of the point. We learned that the adjacent value would be x and the vertical displacement would be y, making this right triangle. And way back in the day, we learned that x squared plus y squared on a right triangle would be equal to this r squared, my radius. So x squared plus y squared equals r squared. And so I get a negative 6 root 2 squared plus a 6 root 2. Oops, I put the negative on the wrong one there. When it's a point P, what is the value of R? Yeah, sorry. This was my P value right here. So my X is positive, my Y is negative. And so now we do the math for that. And so that would be 36 times 2. We do have to square everything in here. So 6 squared is 36. The square root of 2 squared would just be 2. So 36 times 2, which is 72. Now this is a negative, but being squared. And so negative 6 times negative 6 gives us a positive 36. So that does not change. It's still, it's not still positive. And so we get 144 is equal to R squared. And so R would be equal to 12. Now, when we take the square root of a square like this, we would want the positive and the negative, but because we're talking about the radius here, we can say it's the absolute value, the positive 12. All right. So with that, we're going to shift to our unit circle points. The unit circle is a crucial part of AP Pre-Cal and your future math classes. So we're going to start learning them now, but you're going to learn them deeply and know them forever. All right. So consider the unit circle with points P, Q, R, S labeled above. Find the values of the following. So we've started with our points on the X and the Y axis. Those are going to be the easiest to know. So we started with those. Cosine of 0, we're talking about this point right here. This is the unit circle. So when we see the unit circle, that is a circle with a radius of 1. So with our radius being 1, and knowing that cosine of theta is x over r, and sine of theta is y over r, with our radius being 1, then that is just x and that is y. So the cosine of 0 would be 1. The sine of 0 would be 0 because that's the y value there. Now we go over here to pi over 2 because this is 0 radians. This is pi over 2, half of pi. This is pi and this is 3 pi over 2, and we know all the way around is 2 pi. So our next one here is on the y-axis, that's pi over 2. And so my cosine of pi over 2, that's 0. My sine is 1. All right, at pi, my cosine is negative 1. My sine is 0. It's a 0. All right, at 3 pi over 2, my cosine is 0. My sine is negative 1. Those are the easiest ones to learn, so get those taken care of very quickly. All right, now we're going to talk about the larger portion of the unit circle, which is all of our other angles. The angles that we have been working with on the unit circle involve multiples of pi over 4 and pi over 6. Those are the ones that we did last class when we started talking about it in topics 2.2. So here is an example of one of them. We're going to start with pi over 6. It tells us that theta is pi over 6 right there. Again, we have our equilateral triangle. So this is going to be a reflection here. Now we see that our radius is 1, so we're talking about that unit circle, and we see that our y value is 1/2 right here. And so now we want to come up with the rest of that. So if you think about your 30, 60, 90 triangle right here, because pi over 6 is at 30. And so I always want to refer back to what you did learn in geometry just to make sure you're keeping up with me here. So that's our 30, 60, 90 triangle. These are the rules that you learned in geometry. So technically you can take this right here and set it equal to 1, and we would find that x is 1/2, which gave me this part right here, which is this. And then you could put 1/2 here, and this would become √3/2, so you would find the x value. That is one of the ways, if you remember those rules for special right triangles from geometry. Now we're going to go through and prove that a little bit here on the bottom. It tells us that the unit circle has a radius of 1, so we know this radius. With an equilateral triangle inscribed inside the circle, the angle shown above will have a measure of pi over 6 radians. We can see that the y-coordinate of the point is 1/2. We can use Pythagorean theorem to find the x-coordinate. So x squared plus y squared equals r squared. Remember Pythagorean theorem. We plug in the 1/2 for the y and the 1 for the r, because those are the two pieces of information that we can get. And so then x squared plus 1/4 equals 1. That leads to x squared equals 3/4. And so then we take the square root, and remember that is a plus or minus, and so we get plus or minus the square root of 3/2. Since point P is in the first quadrant, we know that the x-coordinate of P is the square root of 3/2. We took the positive one because it's in the first quadrant. Now, if it was in the second quadrant right here, then we would take the negative. So that's what that means. And the coordinates of P are square root of 3/2 and 1/2. So this point right here is square root of 3/2 and 1/2. We've kind of showed you both ways. Here's the 30, 60, 90 triangle that you learned in geometry. Here's using Pythagorean theorem, but that is definitely the point for pi over 6. Since we said cosine of theta is x and sine of theta is y, we know then that cosine of pi over 6 is going to be the square root of 3/2, and the sine of pi over 6 is going to be 1/2. So two important notes. Notice that we found two values of x when solving with the Pythagorean theorem. This is because there is another point in quadrant 2, like I said earlier, of the unit circle with a y-coordinate of 1/2. Using symmetry, this point would be at 5 pi over 6. And then the Pythagorean theorem plays an important and interesting role with trigonometric functions, so we will see additional ways that the Pythagorean theorem becomes useful later in Unit 3. And so here's an example of that point again. And we're going to fill out the table here. So we just did this one, point P, where it was pi over 6, and it came out to be square root of 3/2 and 1/2. All right, so the point on Q, we said that's when we saw that negative when we solved. And so this would be negative √3/2 and 1/2. It is a reflection across this point right here. And so y is the same exact thing when we reflect it across the y. The x's are the one that change signs. Now, when I reflect it again for this point R, we would get negative √3/2 and 1/2. And when we reflect this across the x-axis, our x stays the same and our y turns positive. So we have just come up with those 4 points with the angle measures of 6 underneath. So see if you can fill out your table here for those angles, and go ahead and pause the thing. I'll pause it and fill it out so we can check our work. All right, so check that you've written those coordinates correctly, so that you do have them to fill out the unit circle afterwards. So it says, just as we did earlier in these notes for an angle of pi over 6, we can use the circle along with the Pythagorean theorem with angles that are multiples of pi over 4 by drawing 4 isosceles right triangles inscribed in a circle. So we just did the pi over 6s. Now it's time to do our pi over 4s. So here is an example of that. And so since we are using an isosceles right triangle, x is equal to y. Using Pythagorean theorem, then x squared plus x squared equals 1. So 2x squared equals 1 and x squared equals 1/2. And then, of course, when we take the square root of a square, plus or minus equals 1 over root 2. Now, just off to the side, we did talk about rationalizing last time. So one more time, anytime that you have a square root in the denominator, you rationalize by multiplying square root of 2 over 2. And so that becomes root 2 on the top. On the bottom, that's going to be the square root of 4, which is 2. All right, so that's where they got this x and y value. Again, that was because this was a 45, 45 triangle. Actually, I drew that wrong. Sorry, I put that on the 90. This is 90. This is 45 and 45. So I'm just going to draw the 45, 45, 90 here from geometry so that you can remember it. Again, all of our answers need to be in radians. So I'm only showing you the degrees so that you have reference points from geometry. So with this, you learned this was x, and this was the square root of 2. Sorry, x square root of 2. And so when we multiply that x value times root 2 here, that's where that's going to become that 1 value. All right, so with geometry or Pythagorean theorem, we've kind of just proved them there. We've shown you what that is. So this was our point, root 2 over 2, root 2 over 2. Now we're going to go ahead and reflect. This one I'm going to let you go ahead and reflect them, come up with the symbols, and fill out the coordinates here. Give it a try to make sure you can do it, and then you can check my table afterwards. All right, so I have filled out my table, checked to verify that it is with your table. These are all the angles that have a denominator of 4. So first quadrant, second quadrant, third quadrant, and fourth quadrant. I hope at this point you're seeing some patterns in what's happening. I'll even point out a few in which quadrants, which values are negative. So second and third quadrant, we see the x's are negative. In the first and fourth quadrant, we see that the x's are positive and the y's are negative. Those are the kind of things that you need to start looking at. Also, the pattern that these are all angles of 4, and they have the same x and y values with only that difference of signs. Just like it was on the pi over 6, the ones with the 6 underneath all had the same x and y coordinates. That's going to help you learn this circle really well and very quickly. We are going to do it one more time. That last angle that we have in the unit circle that we need is the one with the 3 underneath. So this is pi over 3 that we're looking at here. This is a 30, 60, 90 triangle again, but in this case, we have put the 60 degrees right here and the 30 degrees right there. Now, the pattern does not change from the one that we looked at earlier. So just like earlier, across from the 60 is the x root 3, across from the 30. Oh, I did not write that correctly. Let me rewrite that. 1 second. There we go. 30 degrees. Across from the 30 degrees is the x, across from the 60 is the x root 3, and then the hypotenuse is going to be 2x. That's from geometry. Now, when we make this hypotenuse 1 for the unit circle, then we find that x is 1/2. So now my x value is 1/2, we see there, and our vertical displacement is the square root of 3 over 2, giving me this point right here. Again, they're equilateral triangles, so we have 3 of them here, so that's going to give us our 3 angles. Our pi over 3 here, this would be the 120 angle, so we said that was 2 pi over 3. And then our 3 pi over 3, of course, is the pi, and then right here we would get 4 pi over 3, and then our 5 pi over 3. So go ahead and fill out the table one more time with our points and our reflections so that you have those angle measures and you have those coordinates so that we can make sure we learn that unit circle. All right, so I've got my coordinates now for the ones that end with 3. That's our pi over 3, 2 pi over 3, 4 pi over 3, and 5 pi over 3. Make sure that your coordinates are written correctly. Again, you see these patterns where the x's are all the same number with just the sign changes. Our y values are the same except for our signs. All right, so time for the big reveal, the whole unit circle together. We've cut it into pieces, got all of our parts. So here is our unit circle. These are all the angles that you're responsible for knowing. It is just the values that we just came up with. So our first angle here, pi over 6, pi over 4, pi over 3. Those are the ones that we stuck to. And then we just reflected. So keep that in mind when you're learning the unit circle. If you know this first quadrant, you really know the entire unit circle because they are just reflections from one side of the unit circle to the other. We also know that cosine of theta is equal to x. Sine of theta is equal to y. And we even know tangent of theta is equal to y over x. So you should be able to instantly be able to give the cosine and the sine and the tangent because all you have to do is look at the coordinates. So if we said, what's the sine of 2 pi over 3? I would go to angle 2 pi over 3, and I should know that it is the square root of 3 over 2. You should be able to do that for any one of the angles in the unit circle, which is all of these done here. Now, there are tons of different ways that you can learn the unit circle out there. I will show you a couple of the quick shortcuts that you can learn. So my x values here, it starts with, they're all over 2. So every single one of my denominators is 2. Now for the x's, it goes 3, 2, and then 1. And then for the y's, it goes 3, 2, and 1. And then we reflect across, and that's going to be true for all of the points. So that's one of the ways of learning those right there. For learning the angles, on here we see that the denominator 6, 4, 3. Once you know those, you know the entire unit circle. Because on this side, it is whatever that denominator value is over 1. And so this is for the radians. It is the denominator plus 1. I'm sorry, minus 1. Goodness, what is wrong with me today? D minus 1. So 3, so 1 less would be 2. 4, 1 less is 3. 6, 1 less is 5. And for our third quadrant here, this is where it's the denominator plus 1 over d. And so if our denominator 6 plus 1 would be 7, our denominator is 4 plus 1 is 5, our denominator is 3 plus 1 is 4. And then for our last one here, it's 2 times the denominator minus 1 over that denominator. So right here, we double, that's 6 minus 1 is 5. We double, that's 8 minus 1 is 7. We double, that's 12 minus 1 is 11. These are tricks. Whatever it takes for you to learn that circle is what I want you to do on there. But you should know those 30, 60, 90 so well that you've got all those points. Recognize that this is x comma y. In this quadrant, it's negative x, positive y. In this quadrant, it is a negative x and a negative y. And in this one, it is a positive x and negative y. So you should know whether it's going to be a positive or negative when asked. You can think about that as well. Cosine is going to be negative here. Sine is going to be positive. They will both be negative here. And then cosine is positive. Sine is negative on this one. There's a trick to even know that. We say all students take calculus. So they are all, get you a better view there. Here we go. They are all positive here. Sine is positive here. Tangent is positive here. And cosine is positive here. So all students take calculus helps you remember that. These are the ones that are going to be positive. So as soon as we say sine of 7 pi over 6, you're going to know it is negative because it's in the third quadrant. Lots and lots of ways of learning this. There's even a trick on your hand to know these coordinates. And so if I put my left hand right here, my first angle, that's our pi over 6. We see that one right there. This is your x value, so square root of 3, and they're all over 2. And this is your y value, 1 over 2. I drop this one down, and I want to go to pi over 4 next. So I fold this one. This is my x value, square root of 2 over 2. This is my y value, square root of 2 over 2. Now our last angle in this first quadrant, that's my pi over 3. And so my x, 1 over 2, my y, square root of 3 over 2. So even the left hand helps you figure out how to get this unit circle down. Again, you do what you got to do to learn it. All right. So finally, here's what they look like. Sine 2 pi over 3. 2 pi over 3 is right here. The sine is the y value. So my answer here would be root 3 over 2. I'll do a couple of these with you. Cosine 5 pi over 4. 5 pi over 4 is right here. Cosine is my x value. And so I get negative root 2 over 2. Cosine 11 pi over 6. 11 pi over 6. Cosine is the x. This is root 3 over 2. And try this one, 7 pi over 6. If I do the hand trick right here, 6 is this first angle. Sine is my y value, so I know it's negative 1/2. 7 pi over 6 is in the third quadrant where I know it is negative, so that is negative 1/2. That's how you're going to be able to answer these. You should be able to answer them quickly. Remember, these are the ones on the axes, so you should be able to respond to those pretty quickly. Cosine 5 pi over 3, angle 3 is this one here. Cosine is my x, so that's the 1/2. That's in my fourth quadrant, so it's positive. All right, do your best to learn that unit circle.